Hi everyone, I'm Ozgun and I'm super excited to be here. Today I'm going to talk about frontier AI models and open source frontier AI models and the tremendous amount of change that we've seen with these models in the past 9 months. And since the talk is only about 20 minutes or so, I'm not going to dive into every single detail. The talk will primarily be on accuracy, quality, benchmarks, the progress that we've seen over the past 9 months in quality, model quality. And I also have a mini parentheses, as a mini talk within a talk on AI reasoning models. Because prior to this year, I think all of it was around general purpose LLMs. This year in 2025, AI reasoning models had a hit. So I'll talk a bit about AI reasoning models as well. All right, with that, let's get started. Well, first to kick things off, who am I? I'm Ozgun. I'm one of the founders here at Ubicloud. We do DeepSeek for enterprises. And I co-founded 2 companies. Those 2 companies were Cytus Data and Ubicloud. We did a program called Y Combinator. And that's relevant for this talk because about 95% of the things that I'm going to share in this talk is feeding in from that network in San Francisco. The other thing that's interesting is I did 2 big companies, Amazon and Microsoft. That's relevant because my background is actually in distributed systems and databases. I'm at this phase in my life where I'm reconfiguring myself for AI. And it's changing way faster than I thought it would. And I'm fortunate because it's not only me, everyone over 20 years old is in this reconfiguration phase. So I'll talk a bit about that with one example. It hit me earlier in the year when I was reading this paper on fine-tuning models for reasoning. And typically when I read these papers in databases or distributed systems, there is this paper that came in 1980, and then you go to 1990. There's a few papers in 2000s and a few more in 2010s and whatnot. So that's usually what you see in the introduction and then the abstract sections. And I was reading this paper that came out March 1st in 2025, and I realized I was looking over to the references that there were 11 references in here, and I'll call them out, and all of them were from 2024 and 2025. And that's exciting for me just because I've seen more change in this field than I had seen the 20 years before. So it's changing at this rapid pace, and then that's what I'm going to focus more on the foundational model side of things in the rest of my talk. Before the talk, I'll give you how we're going to end up. So this is from artificialanalysis.ai, that's the website. You don't need to worry about the numbers in here yet, because that's the talk. I'll walk you through it. But there are 2 things that I'd like you to keep in mind in the context of the talk. First is I did not pick all the AI models out there. I picked 2 proprietary models from OpenAI and Anthropic. That's the OpenAI and Claude models in here. And I picked 2 open source models, DeepSeek and Llama. So those are the 4 models that we're going to be focusing on throughout the talk. The other thing that's important to keep in mind in the context of this slide is in this benchmark, every 5 or 6 points gets you to a new league. So it's like you can think of a model that does 5 or 6 points higher than the other ones as being 1 more notch above. So those are the 2 things to keep in mind. Everything else you don't need to worry about just yet. Right. Is the pace good? Like, am I going at a good pace? All right. Now I'll take you back to October 2024, like we're rewinding by about 9-10 months, which is where the talk starts. And I'll share 2 things in this slide. Of course, the number of models is much fewer. The first thing is at this point, we went to our Y Combinator network and we asked these guys, hey, state-of-the-art open source model is Llama 3.1. If we gave you this model for free, like inference for free, would you use it? And the answer surprised us because they said no. No, because OpenAI's 4.0 model is actually more powerful. It's 1 notch above Llama 3.1. So instead of using something that's for free, we'd rather use something that has higher quality. So that's the 5 or 6 points being enabling new capabilities. So that was one learning. The other thing that was interesting that came as a shock to the market was OpenAI announced O1 preview. The prices were quite high, but if you looked at the capabilities of this model, it was not 1 or 2 notches above, but it was like fundamentally better than the other models. So it positioned all the 3 other models in here as general purpose LLMs, And this is the point at which we started thinking about reasoning models. There's a new class of models, reasoning models. Expensive, but it was out there and it was very capable. So that's 2024, and I actually thought at this point, okay, OpenAI is going to maintain this lead for years to come. But then fast forward just by a couple of months, and then this actually unknown startup launched a model called DeepSeek. And it really shook the AI world in two or three ways. One was, for the first time ever, there was an open source model out there that was as good as proprietary models. And that also came out as a shock, like to Silicon Valley as well. The other thing was, this was a reasoning model. You could use it in the way that you could use OpenAI's O1, and it changed the price performance characteristics of the models out there. And this is the point at which, this is January 2025, where we started thinking about, okay, why are these models, reasoning models, game changers? Prior to that, we had general purpose LLMs, and now we have these reasoning models. Why are they so interesting? I'll open my parentheses, go into my mini talk, and I'll start showing you why through an example. So here's my video, and in this video, we're first going to ask a math question to a general purpose LLM, and we'll ask it to make the equation correct by adding parentheses and make it equal to 479. So this is Llama 3.3 at the time. It will use the data it's been trained on, find patterns, and try to use those patterns, but in the end, it will come up with the wrong answer, an incorrect answer. That's because this question is not in the model's training set. Then we'll ask the same question to the DeepSeek distilled model. And then this DeepSeek model, instead of simply pattern matching, guessing the next token and whatnot, you see in the think tokens, we'll start thinking about the question itself. It will actually understand that the equation is incorrect, and then it's going to start applying different heuristics and techniques for searching for an answer. This is going to take a while, a couple of minutes. I won't show you all the reasoning steps, but it's trying one thing, then it's trying another thing, and in the end, it will actually find the answer. It will verify its answer, and then it could start with a question that it has never seen before and solve that question. So the question is how? Like how could it do this? The answer to that question starts with a paper published by Google a little earlier, like about a year earlier, called Chain of Thought Prompting. This paper, Google's paper, first takes a general purpose AI model, a weak AI model, that's on the left-hand side there, and it asks a simple math question. Because this is an earlier AI model, you'll see the question, but the LLM will get confused, and it will provide you an incorrect answer. Now, what the researchers did was very interesting. They will ask the model the same question, that's on the right-hand side, the same question, but before that question itself, they will ask a different math question. They will provide a different answer to that different math question, and they will provide reasoning steps. That's the part that you see in blue in there, the reasoning steps. And something very interesting happens when they do this. It leads to an emergent behavior. The AI model starts using reasoning steps as well. And when it uses those reasoning steps, the model can invoke the knowledge that it already contained, and through this knowledge, the same model, by thinking out loud, can answer the question correctly. This is the emergent property is very interesting to me. And then what the researchers saw that the more and more the model thinks out loud, the better it gets in answering these questions. Like in the example in here, over basically on the y-axis, you see how well the model performs in terms of accuracy benchmarks. And in the x-axis, it shows you how many times you prompt the model thinks. And then the blue line here shows the model's performance with chain of thought prompting. So that was the paper that was actually the changer in a way. And so the trillion-dollar question is then this. General purpose LLMs have this emergent property where when you provide the right prompt, they start to reason. Given this property, how do you generalize it? The current answer is teaching the model how to search over a solution space in steps. You then reward or critique the model in each step, and then teach the model to verify its results. Here are 3 different ways in which AI models can actually search over the space. And when the model learns different ways to think or search for an answer, it could then apply that thinking strategy or those thinking strategies when it sees new questions, which is what we saw it do in the previous video. So this is reasoning through the answer. But how do you teach an AI model, a base LLM, a general purpose LLM, how to think? Well, the answer is simple. You get a high quality data set there. Let's say you get 10,000 math questions. And for each question, you provide reasoning steps and the answer. Not just the answer, but the reasoning steps and the answer. Then you take that base LLM, you fine-tune that base LLM with that data set, and then the model learns how to reason, and it becomes a reasoning LLM. OpenAI's O1 model was the first one to do this. And when it came out, it shattered accuracy benchmarks in verifiable domains. Here we see in math, let me see if I can get my pointer. Well, in math, in sciences, in coding, O1 could perform at the level of, or sometimes even better than a PhD student. And many thought, including myself, that OpenAI's advantage with reasoning models would last a long time, maybe years. Then DeepSeek R1, as I shared, took the world by storm in January. Coming out of a research lab in China, R1 showed that it could outperform sometimes, or at least as well as O1 in these reasoning benchmarks. And what made DeepSeek exciting wasn't that it matched O1's performance, but how it did it. DeepSeek researchers published the model, one as open source. In fact, they published all their work. And suddenly, anyone in the world could deploy and use models as powerful as OpenAI's anywhere in the world. This also led to a dynamic where people could use DeepSeek R1 at a 10th or 30th of the price of OpenAI's O1. We think this is amazing. And even that in by itself would have been a big leap, like October and then January in terms of reasoning models, and then like the open source reasoning models. But go for a few more months. In April, Llama 4 came out, Llama 4 Maverick. Now, Llama 4 didn't perform as well in accuracy benchmarks as DeepSeek, so that was kind of a bummer. But it was a multimodal AI model. So suddenly we had access in the open source world to high quality vision models. What does this enable? Previously, people used to use proprietary models for, say, optical character recognition, OCR use cases. So you'd go to AWS, you'd go to Microsoft, or you go to these proprietary users out there. But here, with Llama 4, you could suddenly feed that data into Llama 4 and take care of use cases like OCR within enterprises. So that was the big change in April 2025. And we didn't stop there. Fast forward to August 2025. Here, DeepSeek and OpenAI had updates to their models where we had another notch, or maybe two more notches in terms of accuracy benchmarks. This is the slide that I shared early on, and then this is my last accuracy slide where we see progress from all the way in October, November, in Llama 3.v 70B in open source models to today, where OpenAI's open source model fits into 1 or 2 H100s, depending on how you quantize. And DeepSeek's new model does really well in coding benchmarks, in SUI bench verified. And then we're in a world where we have much better models that are much more compact and much more powerful. And that's actually more or less what my talk is. I'll wrap it up, I'll conclude, and then take questions. But I'm super excited, because if you just go back 9 months and to today, we saw 4 fundamental changes in AI models. One, we saw reasoning models coming out of OpenAI first, and then the other guys. And then that led to a leap in capabilities. 2, we saw open source models suddenly that could perform almost on par with the proprietary models. And then through those changes, we also saw a huge improvement in price performance. I have an example here where the token prices were at for inference earlier in the year. Suddenly, we went from $60 per million tokens to $2 per million tokens. Now you have other open source models that are actually even cheaper than that. So suddenly, we have a 30% decrease in price, even with higher quality. And we also have access to multimodal models. And I think a lot of that is credit to DeepSeek, Qwen, and Llama 4, open source AI models, making the open source world and then the AI world get better. And for us, this is super exciting because everything we do is with open source. We enable DeepSeek for enterprises, and we're here to take questions. In fact, we have a talk later in the day at 3:15 in our booth, like where we're going to show different applications of these open source AI models. We'd more than be happy to have you there, show us your demo, show you our demo, and then yeah, thank you. Thanks so much. I left quite a bit of time in the end because I was zooming through the slides for questions. So for anyone who'd like to ask questions, yeah, I'd be more than happy to answer them. Yes. Could you speak up?
Okay. So I'm wondering what is the performance of the new model, the 120 million parameters, and if you think it's better on the time, but also in use cases.
Yep, thank you. The question is, I wonder if you have benchmark results for the new OpenAI's open source model, right? And then in which workloads and use cases do you see it perform? Is that right?
It's more of if you think it was fine-tuned for benchmarks, or if it was fine-tuned for benchmarks, or it's useful also in the day-to-day use cases.
And then I guess a follow-on question is or maybe the replacement question is, do you see GPT, the open source OpenAI model being useful actually outside of the benchmarks? Is that right? That's a good question. Now, if you look at the benchmarks, and everyone trains with the benchmarks as well, so it does perform really well in the benchmarks. We don't see its adoption in coding use cases that I know. In other use cases, I think people are playing around with it, but personally, I haven't its usage in real-life scenarios as much as I've heard DeepSeek or Qwen. That may be because the model is new, and it's trained on synthetic data, or it's trained on synthetic data, I don't know yet. Does that answer your question? Yeah. Awesome.
Just a high-level question on the reasoning model versus using like a long set of functions and function calling. How do you think about when it's optimal to do one versus the other?
So I think the question is, how do you think about reasoning models versus using reasoning models with tool calling versus using general purpose LLMs with tool calling? Is that right? I think in general, the next frontier seems to be today around better tool calling. Like if you look at GPT-5 in here, yes, I put it there, and then it has a leap versus other models. Most of those benefits come from its integration with tool calling and its ability to route to general purpose LLMs or to reasoning LLMs. So in the context of tool calling, I think any kind of tool calling done properly helps, and then that seems to be the direction right now where these companies are going to. Between general purpose LLM and reasoning models, I think in general reasoning models work better for verifiable domains where there is an absolute answer and where you'd like the model to think and you're okay with waiting. General purpose LLMs work better when you're just asking a simple question and then you're waiting for the answer. I'll add one more thing into that in that context where if you're using a general purpose LLM, you're typically teaching it or asking questions and you care more about the how. And if you're using a reasoning model, you care about the what, and people dump a lot of information into the context window. And then you'd like the model to figure out what you'd like it to accomplish. Those are the general differences in between the models.
So I'm starting to scratch the surface of all this AI. I use it myself when I program, but I've not used any open source and downloaded them and tried to trade it with it. So I apologize if my question is dumb. So is
The field is very new, and then I'm learning too. I think there are two questions. The second question is, DeepSeek is from China. Do you see any risk with using open source models from China? And then the first one is, how do you track the popularity of these different models? On the first question, we hear most, and I think there are benchmarks, Olama and others publish results. You could go to OpenRouter, they publish which models are used mostly. From an open source standpoint, the ones that are mostly used that we hear are DeepSeek, Quan's models, and then Llama 4, but Llama is lagging behind because it's not frontier anymore. So those are the top two models that we hear. Probably Olama and OpenRouter are a good place to look at to track popularity for those models. On the second question, do you see any risks? There are risks, but the models are open source. So you could download the model, you can test it for yourself, for your workloads, and then see how it does. There are concerns around censorship in the model. If you ask it politically sensitive questions about China, it's not going to answer. But the nice thing about it being an open source model is you can actually remove the censorship. Like there is work, in fact, our team was like, you can say fine tuning or removing the censorship of the model where you detect how it's censored and you remove it, you fine tune it, and suddenly it becomes a regular model. You can make the model Dutch if you'd like. So although the risks are there, because it's open source, you can remove those risks. That's a really good question, and I don't know if anyone knows the answer to your question. Like, I guess in terms of, I think the question is, let me repeat the question first. With transformer-based models, are they reaching a cliff? And do you see other types of models being able to remove that cliff? I don't know. I don't know if anyone knows. OpenAI in every announcement says we're almost at like general like AI, I guess because they have this contractual relationship with Microsoft. It's hard to say. It's been going at a rapid pace. There's been kind of a cliff coming, like GPT-5's biggest win is not that the model is like more powerful, but then it has more tooling integration. I don't know the answer to your question, and I don't know if anyone knows. It's a hot topic in AI these days, and maybe there are only a handful of people who could credibly answer that question. On that question, no, we're not actively looking at other models than transformer-based architectures, primarily because if you just take DeepSeek in here, or if you take Quan, we think the challenge is not how well these models perform. We think the challenge is you take this model, it will take an enterprise 5 years to properly deploy this model and make use of it. So even if there was no progress with the open source models or with the models today, we don't think the bottleneck is with what the model can do. We think the bottleneck is how the model is applied and used within an enterprise or even a startup setting. So we're focusing our energy more into how best is this model used in an enterprise setting, because that's at least another 4 or 5 years. One last question. So the question is, in order to make these models useful, do you do fine-tuning within an enterprise setting? The answer is yes, we can. We've also found that with reasoning models, big RAG pipelines do as well as fine-tuning use cases, because you dump everything into the context window and then the newer models can figure those out. So we do a combination of both, actually. We have a demo at the end, at 3:15. Happy to chat more there. Thank you. Thanks a bunch.